How we could discover quantum gravity without rebuilding spacetime. Hello everyone and welcome back to our channel. Today, we are going to dive deep into the world of quantum mechanics and discuss a fascinating topic known as quantum gravity. For years, scientists have been trying to unravel the mysteries of this phenomenon, which describes the union of two fundamental theories of physics, quantum mechanics and general relativity. In order to understand what quantum gravity is, we first need to understand what these two theories are. Quantum mechanics describes the behavior of matter and energy on small scales, such as those found in atoms and subatomic particles. It explains things like how electrons move around atomic nuclei and how particles can be in two places at once. On the other hand, general relativity describes the behavior of large objects, such as planets and galaxies. It explains the curvature of spacetime and how objects move under the influence of gravity. Now, you might be wondering what the connection between these two theories is and why we need to unify them. Well, the problem is that they don't seem to play well together. Quantum mechanics breaks down when trying to make sense of gravity, and general relativity struggles to explain the behavior of tiny particles. This is where the concept of quantum gravity comes in. It attempts to reconcile these two theories into one comprehensive framework. Now, the question is, how do we discover quantum gravity without rebuilding spacetime? This may sound like a daunting task, but scientists have actually come up with a few different approaches. One such approach is to use gravitational waves. These are ripples in the fabric of spacetime caused by the movement of massive objects, such as black holes. By observing these waves, we may be able to detect quantum effects that would indicate the existence of quantum gravity. Another approach that scientists are exploring is the use of high-energy particle colliders. These machines can smash elementary particles together at incredibly high speeds, allowing us to study the fundamental building blocks of the universe. By studying the behavior of these particles under extreme conditions, we may be able to detect quantum effects that would be indicative of quantum gravity. So, why is it important to discover quantum gravity? Well, for one thing, it would allow us to better understand the behavior of the universe on both large and small scales. It would also help us to develop a more comprehensive theory of everything, which could help us solve some of the biggest mysteries of science, such as dark matter and dark energy. But perhaps most importantly, discovering quantum gravity could have practical applications as well. For example, it could lead to the development of new technologies, such as quantum computers, which have the potential to revolutionize the field of computing and information technology. In conclusion, while the discovery of quantum gravity may seem like an insurmountable task, scientists are making strides every day in understanding this phenomenon. By using approaches such as the study of gravitational waves and the use of particle colliders, we may be able to uncover the secrets of this elusive force and unlock a wealth of knowledge about the universe. Thank you for joining, and be sure to subscribe to our channel for more fascinating content. Thanks for watching.